On example 5, we're supposed to simplify the cube root of 343. So I look at my table of cubes and notice 343 is one of my numbers, isn't it? The cube root of 343 is 7. So you don't have to do too much on this problem. It's 7. How about 135? Well, the difference now is 135 is not a perfect cube, is it? 125 is, but that's not a perfect cube. So let's look at numbers less than 125. Does 64 go into 135? No. Oh, but 27 does. So we're going to say the cube root of 27, 135 divided by 27 is 5. So the cube root of 27 we know is 3 cube roots of 5. And there's our answer. Now let's take a look at example 7, one a little bit more complex. So first off, I look at 36, and 27 doesn't go into 36, nor does 8. So what do? Well, here's what I'm going to do. I'm just going to make a regular factor tree. Whoops, need that. So the cube root of 36. I always like to start with the smallest, but you can start with any number you want. 2 goes in to 36. It goes in 18 times, because 18 times 2 is 36. I'll do it again. 2 goes into 18 9 times. I didn't write my 2 right away. And then 9 is 3 times 3. Now it's prime factorized. Notice there was this cube root of 2 to start with, times the cube root of 2 times the cube root of 2. In other words, I've got the cube root of 2 3 times. Oh, that's plain 2, isn't it? Because they reduce each other out. I've got the cube root of 3 twice. So that's the cube root of 9. So this simplifies to 2 times the cube root of 9. And there's our answer. Now in example 8, I've got this fraction. And anytime I got a fraction, I always say I'd like to work with smaller numbers. Is anything going to both of them? Well, at first, I know 5 goes into 375. Doesn't look like it reduces, but notice, if I add the digits, what's 1 plus 6 plus 8? Well, that's 15. 3 plus 7 plus 5. That's 15. Not that 15 goes in both of them, but I know 3 goes into 15, so 3 must go into both of them. So what I'm going to do is I'm going to divide both of these by 3. And if I divide both of them by 3, I get the cube root, the cube root of 56 over the cube root of 125. Well, from my table, I can look and I can see the cube root of 125, that is 5. So I get plain old 5 there. Now I look at 56. Whoops. I always forget to change that. Now 56. 27 does not go into 56, but 8 does. So I'm going to make a factor tree for the cube root of 56. That's the cube root of 8 times the cube root of 7. And I know the cube root of 8 is 2, cube root of 7. And there's my answer. Let's look at one with fractions and all that other fun stuff. Okay, 15 and 81. First thing I notice is 15 divided by 3 gives me 5. Divided by 3 gives me 27. So I'm going to have the cube root. I'm going to split this up. I'm going to do my numerator and the cube root of my denominator. Now, x squared and x to the 5th. I want to keep my exponents positive, so I'm going to say 5 minus 2 is 3. But it'll go in the numerator, or said that wrong, in the denominator, because 5 is bigger than 2. I've got y cubed, and I'm going to split up z to the 4th because I want multiples of 3 now, not just even. So 3 is a multiple of 3, but 4 isn't. So I'm going to say that z times z cubed. Now I will simplify those. 5 does not simplify, does it? So I'm going to say the cube root of 5. And then the cube root of y cubed is y. That's going to go on the outside. The z, I can't take the cube root of. And z cubed, I'm going to put that on the outside. In my denominator, the cube root of 27, I look at my chart, that's 3. Should get that one memorized. X. The only thing I don't like it when it's not in alphabetical order. It just bothers me. So I'm going to rewrite that as y cubed z, cubed root of 5z, all over 3x. Notice, nothing simplifies. 3 doesn't, the 5 is in the cube root. Even if it did go, it wouldn't simplify, because I have to take cube roots divided by cube roots. And now I got y cubed, z cubed over 3x, and there is our simplifying. You'll notice you don't have a lot of problems on this assignment because they take a little bit. And hopefully I gave you enough so you learn the material.